Here we have a nearly identical setup to what we had in the previous video. Similar idea, we've got something we don't know, we've got some measurements, and we're given the arc length, but this time we're finding a missing angle rather than a missing radius. Method is going to look very similar, but I will run through it in fullness and give you a chance to practice it just so you see all the details. So arc length here equals angle over 360 times pi d. Now that shouldn't come as any surprise. I've written down the formula because we've got arc length in the question. I've written down the formula with arc length in it. Next thing we're doing is we're putting the numbers we know in. So we've got 52 equals. Now we don't know the angle here. Now be careful. We're putting in a diameter, but we are given a radius. That's one of the most common mistakes that people make, is to not use the right one there. So here we're putting in 20 because that is our diameter. We're given the radius. So just be really careful with that detail. Again, we're going to work out one of our parts here. Now this thing here, these are all numbers. We are on this side, we're dividing by a 360. We've got a pi times a 20. So this side here can be simplified. And again, just using my calculator to do this, I'm just going to do pi times 20, divide it by 360. If you do that and you check on your calculator, you should get 0.17453292, etc. You should keep as much accuracy as you can there, just like we did in our last question. Dividing both sides by this, we get that our angle equals 52 divided by 0.1745329251. Just keeping loads and loads of accuracy, making sure we've got as much detail as we can. Put that in our calculator. We get 297.938, etc. Now, for these questions, I'm always going to give my answer to the nearest degree. You would check in the question if it says otherwise, but at the moment, all the questions I put up are to the nearest degree. So I'm going to round that to 298 degrees, and that is our missing angle. Now, have a go for yourself. So here's the second sector. I'm going to give that one an arc length, and I would like you to have a go with this question where the arc length is 2 meters. So pause the video, try one for yourself, and then once you've tried it, you can watch the rest of the video to check your answer. Super, so if you pause there, hopefully you've had a go, and we'll check out how you got on. So we have angle over 360 times pi d. Putting our arc length in, that goes in there, that's 2 equals angle over 360 times pi times, and be careful, diameter is 8. So if you've made a mistake, it may be that. So check that you put diameter equal to 8 in your working. Next thing we're going to do is we're going to work out that bit as a number. We're doing pi times 8 divided by 360. So we get 2 equals the angle times 0.069811317. Divide both sides by that big number there. So our angle equals 2 divided by 0.06981317. It's a bit of a pain to write these long answers, but it keeps our accuracy really high. You should get, when you do that, 28.64788, etc. To the nearest degree, that is 29 degrees. Okay, as I say, everything I'm going to put up to date, you're rounding to the nearest degree. So that gives you examples of how to find a missing radius in the last video and a missing angle in this video. Our steps are very similar to what we've seen with the circles work though. Write our formula down, put in the numbers we know, and then try and rearrange. And in this case, working that out as a number is our easiest way to rearrange these. We'll have very, very similar strategies when it comes to the work we're going to do with sector areas. Exactly the same kind of layout. Just the formula that we start with will be a bit different. So have a go at the questions on that, and then in task 3, I'll show you how to do it with sector area.